let's go ahead and get started. So I want to start by introducing you guys to a medical imaging process called thresholding. Okay, so and I'm going to show you guys that here in Matlab. Okay, so I just wrote some code here in Matlab. I'm going to bring in an image. I'm going to use the imRead function to bring in this hand.tiff. This is an X-ray image of a hand, okay? And I'm gonna call it img for image, and then we're gonna look at it using the imTool function, okay? So I'll run that, and let me make this a little bit bigger. Okay, so here's an X-ray image of the hand. And again, if you recall, an image, if we take a closer look at this image, okay, recall that an image is nothing but a matrix of pixels, right? Here you can see the individual pixels as I move this box around, right? Okay, and if I zoom in on it, you can see that the pixels are really just a bunch of numbers, okay? And where it's brighter is a higher number, and where it's darker is a lower number. Okay, as I move around, see I'm in a dark region of the image. You see it has low pixel values, around 40 or 50 or 60. If I move this around over to a brighter spot of the image, okay, where the bone is, okay, you'll see that the pixel values are now higher, like 150, 140, okay? And that's because different tissue have different attenuation coefficients, right? And so it's going to attenuate, bone will attenuate more than soft tissue. But because we look at the negative, right, we reverse it, the bone appears brighter, okay, in the digital representation of that image, right? Okay. So let's take a look at a profile of this image. Okay, so if I look at a profile, so I'm going to click once here and drag a line across here, okay, and let's look at this profile, okay. So what has been plotted here, this is the x-axis on the on the image, right, or the number of columns. So columns go across this way, rows go down, okay. So this is the number of columns, okay, and this is the intensity of each pixel at that particular location at that column, okay. And I drew a line across right here, right? Okay, so the pixels right here at the beginning are darker. That's why they are about 30 or 20, pixel value of 30 or so. That's background, okay? Then over here, as I get into soft tissue and get into bone, you can see that the pixels are brighter, okay? About 150 or 160. And then when I get into about here, it gets dark again, and then I reach the other bone, and it gets bright again. Can you see that? Can you guys visualize and understand what we're looking at here? We're essentially just plotting the intensity, the pixel values, along one row across all the columns. okay, where this is the first bone, this is the second bone, okay? So thresholding is a technique where we use a cutoff value. Say we want to identify just the bone, okay? Say we want to examine just the bone. For example, in a DEXA imaging, they want to measure the bone mineral density, right? They need to identify and isolate just the bone, okay? So you can use a technique called thresholding. So if we use some cutoff value, maybe somewhere around here, okay, maybe about 60 or 70 or so, a cutoff value right here. Let's take a look at what would happen to the image. Okay, and the way this cutoff value is going to work is that everything, all the pixels that are greater than this cutoff value, this threshold, is going to turn white, and everything below it's going to turn black. It's going to create a binary mask. It's going to create a binary image where black is 0, white is 1. Okay, so let's take a look at that. Well, but before I do that, let's take a look at a histogram real quick of the image. Okay, so here's a histogram of the image. Okay, remember a histogram on the x-axis, these are the pixel values. Okay, remember they range from 0 to 255, where 255 is white and 0 is black. Okay, and this histogram displays the frequency. Okay, so there are 3,000 pixels in that image that are this pixel value, which is probably about 20 or so. It's dark. Okay, and these are the bright pixel values, and this is how many there are. And this produces a bimodal histogram. Okay, it's bimodal because you can see these two peaks. Okay, any idea what those two peaks are? These are the brighter pixels, okay? The pixels that are, closer to 150, and these are the brighter pixels, and these are the darker pixels, okay? It's just another way to look at, if I cut this, you cut a threshold right about here, I would keep only the brighter pixels. The brighter pixels are the bone. Say we wanted to isolate the bone, we could use a thresholding and threshold this image and isolate the bone. So let's do that. And I've already, if you were doing this on a image that you've never used before, you could look at the histogram and get an idea where the threshold could be. You can look at a line profile and get an idea where the threshold could be. And then it'd be a trial and error process, okay, where you play with a couple of different threshold values and see how it looks. In this case, I've already done it, and I've determined that a pixel value greater than 68 produces a nice image. So here's my threshold, where all the pixels greater than 68 are going to turn white, and everything below it's going to turn black. It's going to create a mask, okay, or a binary image that looks like this, okay? So this is where all the bone is in the image, okay? But it's not perfect, right? Look at, there are some holes here in the finger. There are holes in the finger that shouldn't be there. And that's because the pixel values right there went below 68, okay? So thresholding is not perfect, okay? I'm going to use a technique where I'm going to fill the holes, okay? So I just use this command where imfill, and it'll fill some of those holes, okay? If you take a look at it, you can see that those holes are now filled, okay? Also, you might see some other errors, like up in here. There's a bright spot here, which is bone right there where there shouldn't be any bone, because the pixel value was greater than 68 at that point. So little things like that I'm going to remove, okay, using this function to remove any small blobs, okay. Then I'll use another function to detect the perimeter, okay, to outline the edge of the image. Okay, so that one removed those little blobs that shouldn't have been there. And then I'm going to use this edge detection function to detect the edges. Okay, so here's an outline of the bone. Okay, it's kind of thin, so I'm going to use another function called IMDilate to dilate it or to make it thicker. Okay, it's just going to thicken it up a little bit. Okay. So I just make it a little bit thicker, and then I'm happy with this. Okay, it's a little bit easier to see. Okay, so that's the outline of the bone. Then I'll use another function to overlay it on top of the original image. Okay, and so here you see something that looks similar to what the DEXA imaging system have produced, right? We can identify the bone, and we can now calculate the average pixel value density of the bone, and we can calculate the area, and things like that. Okay, we can do this more further and identify the soft tissue. So I've already done this. I've looked at another threshold value. Let me show you this other threshold value. Okay. So you by shifting the threshold, okay, to everything greater than 31, okay, I'm able to get the outline of the hand. Okay, but of course the hand doesn't have these little holes, and these little white spots out here are not part of the hand, and so I can do some image processing to remove some of those noises, right? One of the image processing I'm going to do is this IMFill. That's going to remove any holes. Then I'll use the BW area open to remove any blobs that are less than 500 pixels together. And then I'm going to dilate it and smooth it out and use this edge detection function. And let's see what it looks like. Okay. Okay, so here I've identified and outlined the soft tissue. Okay, the hand. If I want to overlay the hand, I can do that. Overlay the trace of the hand, I can do that. I'll show you. So here I've outlined the soft tissue in this image. Okay, and if I want to combine both of those and overlay the identified bone and the identified soft tissue, I can do that as well. Okay, so this is what we call computer vision. Okay, so teaching a computer to identify different parts and different features in an image and segment those features using simple thresholding. So this is called image segmentation. Okay, where we segmented out the bone, and we segmented out the soft tissue, and and we did it using thresholding. And then we did some cleaning up of the image as well to remove some of the noise in the image, right? Also, remember this image right here is just a 2D signal. When I draw the profile, let me back up here. I draw a profile across this part right here. This is like looking at the 1D signal of the image. Okay, this is just looking at one row. It looks just like an audio signal, right? Like a voice signal. Uh, um, so an image is really nothing but a 2D signal, right? Where you have rows and columns. And so a lot of the processing that's done in signal processing can be done in image processing, just doing it in 2 dimensions. Okay. Okay, so that's a technique called thresholding. Okay, and that's I just want you to have a basic understanding of what is thresholding. You should understand that it's a cutoff value where everything above it it'll turn on, and everything below it it'll turn off. Okay, and by inspecting the histogram of the pixel values, you can find and isolate different parts of the image. Okay, that's what I expect you to know about that.